Hi students, the given problem is the photoelectric effect, the work function of a metal is 3.5 electron volt. The emitted electrons can be stopped by applying a potential of minus 1.2 volts. So these are the options. So solution for the given problem. From the given problem, the data is, so here work function phi is equal to 3.5 electron volt and stopping potential V is equal to minus 1.2 volt. Here stopping potential is in volts. When we are adding energy equations, the stopping potential equation should be converted into energy form. That means kinetic energy maximum is equal to minus 1.2 volt electrons minus 1.2 volts into minus E, minus into minus plus 1.2 electron volt. This is the maximum kinetic energy gained by the electrons. Already we know, according to photoelectric equations, energy of incident photon E is equal to work function phi plus maximum kinetic energy Ke maximum. Here E means energy of incident photons, phi means work function, Ke max means maximum kinetic energy. So E is equal to, already we know, 3.5 work function plus maximum kinetic energy 1.2. So E is equal to 4.7 electron volt is the energy of incident photons. From this equation, from these options, A is the correct option. Here second option is energy of incident photons is 2.3 electron volts. Actually it is not possible. Clearly indicates that 4.7 electron volts is our answer. Okay, not possible. If higher frequency of photon be used, the photoelectric effect will rise. Actually it is not possible because photoelectric current always depends on intensity of incident radiation. Next, when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. Actually this is also not option. This is not option because here work function is 3.5 electron volts. That means energy required to remove the electron from metal surface is 3.5 volts. That means instant energy is completely converted into work function. So there is no gain in kinetic energy. When there is no kinetic energy, there is no current. Okay. So this is a strong answer. So first option is correct. Okay. I hope I answered this question. Hi students. The given question is, which one of the following graphs shows the variation of the maximum kinetic energy of the emitted electrons with frequency nu in the photoelectric effect correctly? Okay. So from the given data, we know that photoelectric equation, already photoelectric equations we know, H nu is equal to phi plus E suffix k. That means here H is Planck's constant, nu means frequency, phi is work function, E suffix k, that means maximum kinetic energy. Okay, here so we shift phi to the left side. Therefore equation is E suffix k is equal to H nu minus pi. Comparing the above equation with, by comparing above equation y is equal to mx minus c. Okay, so from this equation, y-axis represents maximum kinetic energy, x-axis represents frequency. Here m is the slope, that is equal to Planck's constant h, and c is equal to work function phi. So from the diagram, so y-axis represent Ek and x represent frequency. Next here C is a constant, represents phi. So M represents slope. So we connect like this. Okay. Therefore M is equal to H, that is equal to tan theta. So this is the angle theta. Okay. So I hope I answered this question. Hi students, the given problem is the stopping potential V0 versus frequency nu, plot of a substance shown in figure. So this is the diagram. The threshold wavelength is, in this question they are asking to find threshold wavelength. From this graph, y-axis represents stopping potential, x-axis represents frequency. Here we observe that from this diagram, here zero frequency, that means there is no photoelectric will takes place. 5 onwards graph will rise, that means 5 onwards the photoelectric will takes place. So from the graph, threshold wavelength is, threshold frequency is f0 is equal to 5 into 10 to the power of 14 h. We know that formula, velocity is equal to lambda naught into f0. Here velocity v means velocity of light, lambda naught means threshold wavelength, f0 means threshold frequency. So already we know velocity of light 3 into 10 to the power of 8 is equal to lambda naught, we have to find f0, threshold wavelength 5 into 10 to the power of 14 h. Okay, 30 into 10 to the power of 7 is equal to lambda naught into 5 into 10 to the power of 14. Okay, we cancel 30 by 6 times, 6 into 10 to the power of 7, send this side, 10 to the power of 14 is equal to lambda naught. Therefore lambda naught is equal to 6 into 10 to the power of minus 7. Multiply with minus 3 and divide with minus 3. We will get lambda naught is equal to 6 into 10 to the power of minus 10 into 10 to the power of 3. Therefore lambda naught is equal to 6000 into 10 to the power of minus 10. Therefore lambda naught is equal to 6000 angstroms is our answer. I hope I answered this question.